Welcome dear viewers. Today we are going to discuss about root locus in the control system. Generally, these type of root locus diagrams are used to know the stability of the control system. Here we can observe the path of the closed loop poles, hence we can identify the nature of the control system. In this technique, we will use an open loop transfer function to know the stability of the closed loop control system. So, before knowing the root locus, the basics of root locus we have to know. How the root locus is the locus of the roots of the characteristic equation by varying system gain. Just by varying the system gain, that is by varying the value of k from 0 to infinity, we can find the root locus. We can get the different type of roots. As a result, we can know the stability of the system. Generally, the characteristic equation of a closed loop system is 1 plus g of s and h of s is equal to 0. This is a normal characteristic equation of a closed loop system, where g of s and h of s we can represent as k into numerator by denominator. This k is nothing but the gain of the system. Thus, we are varying from 0 to infinity. Where k represents the multiplying factor, n of s represents the numerator term, d of s represents the denominator term. While substituting these values, g of s into h of s here, we are getting this equation, that is d of s plus k into n of s is equal to 0. Here we are discussing certain cases. If 1 minus k is equal to 0, then k equals 0 here. If k equals 0, then d of s is equal to 0, right? That means the closed loop poles are equal to open loop poles, right? No. So, case 2 is if k is infinity. So, for rewriting the above equation, we will get this term. While substituting k is equal to infinity, then your numerator will become 0. It means the closed loop poles are equal to open loop zeros where k is infinite. From the above two cases, we can conclude that root locus branches start at the open loop pole and end at the open loop zeros. This is one point we have to remember in root locus. Now, angle condition and magnitude condition. The points in root locus branches satisfy the angle condition. So, the angle condition is used to know whether the point exists on root locus branches or not. So, we can find the value of k for the points in the root locus branches by using a magnitude condition. Thus, we can use the magnitude condition for the points and thus satisfies the angle condition. Characteristic equation of a closed loop system. See again, 1 plus g of s h of s is equal to 0, where it is equal to minus 1 plus j. There is no imaginary term here, so we are representing with the help of 0 into j. The phase angle we can represent as tan inverse of the j term minus the real term. So, this is the equation we are using to find the phase angle. So, magnitude is nothing but root of minus 1 the whole square plus 0, which is equal to 1. The magnitude condition is that point which satisfies the angle condition at which the magnitude of the open loop transfer function is 1. So, by these terms, with the help of these terms, we can find whether the stability of the system, that is whether it is stable or unstable or marginally stable. So, these are all the basics. With the help of these terminologies, with the help of these concepts, you are going to draw the root locus with the help of graph, and how we are going to find the stability of the system, that we are going to see in the next class. Thank you.